Hi everyone, this is Byte Relay, and today our guest Maksim Kita again is known for his contributions to ClickHouse. And today he will show us how to hack ClickHouse code.
Yes, so today we will walk through how to make first contribution to ClickHouse, how to build ClickHouse, how to find some issue to work on. And we will create our first pull request. Let's get started. So I will show the necessary screens. So let me, okay. So the first thing that we need to check is ClickHouse repository. So ClickHouse is an open source column-oriented analytical database management system. It's fully open source, so you can just find it on GitHub, open project. You can see there are a lot of stars, a lot of branches, a lot of commits, and other stuff. And you can also see contributors. So there are a lot of contributors in ClickHouse, and I am
1,000 contributors.
Yeah, I'm here. So here also
you are in top 10.
Yeah, right.
Cool.
And you can check issues and pull requests. So we will talk about pull request later in this video, but first thing that we need to find is first thing that we need to discuss issues. So basically, in ClickHouse, whole development process is on GitHub. So there are issues, and for each issue there are a lot of labels. And when you need, for example, there is a question, there is some feature, and when you need to, find something to work on, basically, you can find by label help wanted, and good first issue or easy task. So good for first contributions. So you can see there are a lot of easy tasks, so that you can implement. I already prepared some tasks that we will implement today, so I'll discuss it a bit later. And now if we will check pull request, we can see the whole pull requests that are created. I will show one of my pull requests. So basically it was some fix for context lock contention. You can see that there is changelog entry. So here it's performance improvement, and you write some changelog. So and here you can track. So in pull request you can additionally, obviously there are changed files, there are commits. You can check CI results. So they are basically, for example, you can you can see how CRN for each of your commits, and there is also CI bot messages. So basically, for using these messages, you can check which checks were successful and other stuff.
How many time does it take for CI to pick up your issue and
actually there is I don't know how to say. So basically, CI runs checks your pull request in two parts. First, there are easy checks, so it's fast test, and some other easy checks like style check and other stuff. And if they pass, they will go to other stage when you have whole ClickHouse builds, fuzzers, sanitizers, integration tests, and stateless tests, stateful test for all of these combinations. So basically, to run fast tests is usually pretty fast, or actually around 30 minutes. So you can you can get results in 30 minutes, and so that's and I will also explain flow, how it works. So basically, I have my own ClickHouse fork. It's my nickname, ClickHouse. So basically, when you start development, you fork ClickHouse repository, you create branch that you want to work on, you made some changes in your fork, push them, and after that you will be able to create a pull request to master branch. So you can see from my branch to master branch.
Typical GitHub flow.
Yeah, someone from ClickHouse core team, or someone from, I don't know how to say, ClickHouse approved contributor. So I'm one of them. Can help you with review can mark your pull request as can be tested. So basically, when your pull request is has such label, tests will CI will start to test your pull request. So that's mostly it. Let's so there is a page where you can check what is ClickHouse. So why it's special? It's pretty interesting. So so we probably want to start with how to build ClickHouse. So first, on some vanilla installation, you need to install prerequisites. So we already created virtual machine. We already prepared something so we can move a bit faster. So you just copy this command. For me, it will be all good. So everything is installed. After that, you actually need to install llvm. So ClickHouse does not work with GCC, so you cannot build ClickHouse with GCC. You need to build ClickHouse only with llvm. Currently, you can check which version you need in ClickHouse CI. So basically, you can find output from build and find the version that is used in CI. I know that it's 17. So you can install llvm using automatic installation script. So basically, you download the script. It's actually already downloaded it. Then you make it executable, and then you can install it. So basically, it's something like, and it will the script will install. Then it will add llvm repositories, and it will install all the necessary components. You also can specify all, and in addition, it will install other stuff like clangd and other developer tools. So now I specify it, and it will install everything. For example, probably Clang format and other stuff. Okay. So after we installed Clang, we can check that it's in the system. We can find the binaries. So we are ready to clone ClickHouse repository and start build process. I will show how it's done. Obviously, so we have a ClickHouse repository. You can clone it by HTTPS or by SSH. In our case, I will clone it by HTTPS. So you clone it and you I'll create this directory. So basically, you just clone it as is. After that, so first it will receive some objects and other stuff. So typical flow. After that, in ClickHouse, there are a lot of libraries used, a lot of contribs, and all of them are implemented, are added as submodules. So after you make first clone of ClickHouse, you actually need to check out all the necessary submodules, and ClickHouse currently has more than 100 submodules, and some of them are pretty huge.
Just for the record, Git submodule is a reference from one Git repository to another Git repository. So you don't just check out ClickHouse sources, you also check out 100 different repositories into the same sources. So it might take a time.
Yes, actually, so basically, additionally, after the repository is cloned, you need to fetch all the necessary submodules. Okay, let's one sec. So I'll show how it's done. So we have a ClickHouse folder, and you run git submodule update init recursive, and it will actually take a while because it has a lot of libraries, a lot of stuff. So for example, we use for Git compilation, we use llvm, and as part of ClickHouse, checkout process, you also need to check out llvm and some other big repositories. We already did this in other folder. So let's I will show how build is done. So let's make test build directory. I will show you the command, and I will explain every piece of this command. So basically, you run cmake, you specify path where root cmake file is placed. So here it's my parent directory. Then you obviously specify cmake build type. So for cmake build type, it's actually, you can specify debug, you can specify release, rel with deb.info. Currently, in this video, we will use debug.
Yeah.
Also,
we're going to do some bugs.
yeah, I hope not. One sec. I will. I will continue build. So after that, you specify CXC compiler, so C++ compiler. We will use Clang.
We need both compilers, and C++ and C2.
Yeah.
It's because like you have both programming languages inside the repository.
Yes, some of submodules are compiled not with.
I see.
Yeah.
So you have to compile submodules too.
Yes. Yes, you have actually to compile almost everything. So there are a lot of additional flags that you can use. So for example, as I know, by default, OpenSSL is not compiled. For example, boring SSL is used. So some contrib modules are not enabled by default, but most of the stuff is compiled by default. So when you run this command, cmake will actually do some checks. So it will identify compilers, it will identify features for this specific, machine. It will specify necessary flags, perform some tests. For example, if we have AVX, AVX2, AVX 512, and other stuff.
This is very resemblant to Postgres configuration script. It's just like picking the size of a block, deciding on which provider of SSL you use, and etc.
Yes, it's very similar. Okay, so after so let's wait a bit. So after it will check everything, you will be able to build your binaries, and you will be ready, to go.
Some new features.
Yeah, you will be ready to implement some new features. And we already have prepared build folder. I will just, so basically I will show you the command after this will be finished. Also, one important thing is that when you will work with ClickHouse, most of the developers actually use compilation database. And one second. So here cmake finished, and we can just run Ninja. And by default, Ninja will build all targets, so all binaries, but you can specify only the necessary. So other binaries are ClickHouse is distributed as single binary, so most of other binaries are just tests. Some test binaries, some example binaries. So it's not very important. So let me.
Typically, you run tests on your machine or on CI?
Typically, I run some stateless tests on my machine. For example, if I wrote some unit tests, I also run it on my machine. But if we talk about integration tests and stateful tests, and to run all stateless tests, I usually run them on CI. So locally, I run something only if it fails on CI. Okay, so I jumped to build directory. And now I will show how this compile commands JSON look like. So basically, it looks like this. And you, for example, can find main CPP. So it's some file, and you can see which flags are used, which dependencies and other stuff. So this is necessary for ClangD. ClangD is a language server, and ClangD has good integration with Visual Studio Code, and we will use ClangD. And most of the developers use ClangD. So basically, we have compile commands JSON here, and we can just copy compile commands JSON here, or you can make a symlink. So most of the developers just use symlinks. And after that, I will show you VS Code. After that, you will be able to, after you install the Clang D extension, you will be able to have suggestions, to have code navigation, and you will have commands. So basically, first you need to start language server. So it will parse includes, start indexing. So here we already indexed the project, so everything will work great.
Full-fledged development environment, integrated development environment. You are not a Vim adept.
Interesting thing that I use Vim, but in VS Code. So you can have here there are Vim modes like normal, insert. Here, yeah, it's very convenient. So you use Vim everywhere, but here you get some additional stuff. So, for example, for example, suggestions and other stuff. So let me show you top ClickHouse directories. So basically, there is common. It's a directory with all common components. There is a core directory. It's a bit more specific to ClickHouse, and the most important directories are columns. So column is one of the building blocks of ClickHouse. So ClickHouse is column column database, and columns are the main building block. There is also data types. So data type is it's built on top of column, and it specifies some high level operations that you can do with this column. For example, assume that you have column, it's integer, but you can have data type date, and this date will be built on top of integer column, but provide some operations that are specific to dates. Or for example, if you have some decimal columns can be built on decimal data type can be built on integer column, but in case of ClickHouse, it actually builds its special column type. So currently, different data types for single columns. Mostly it's used for date data types and for some additional data types. Like Boolean data type is probably implemented on top of int8. So just, or column where each values are single bytes.
It's like 8 times more than necessary.
Yeah, it's a bit it's a bit of overhead. Okay, so also there are some other folders. So basically there are functions, there are aggregate functions, dictionaries, a lot of other stuff. And today we will actually look on parsers, on interpreters, and other stuff. So basically, for new developer, it's actually we already did all those steps. So basically, there is instruction how to build ClickHouse, a build about building a bit of information about building process and other stuff. And there is also overview of ClickHouse architecture. So here you can see about column, so about a column interface. One sec, I'll show you. So it's an interface how columns are used. For example, you can ask if column is empty, you can sort column. For example, there is method get permutation. So you can get permutation. So
it's a really huge interface, like very wide. There is a lot of methods.
Yeah.
And like implementing your own column sounds like a great project of enormous workforce resources.
Yeah, actually, columns are not implemented often. So they usually. So basically, if you need some new column, you can build it on top of other columns. For example, from some, I don't know how to say, it's not a new column because it was added a couple of years ago, but column map is actually just a wrapper around array column. So most of the time you do not need to implement your own column. It's interesting that in ClickHouse you can also have a column aggregate function. So this is a column that stores the states of aggregate functions.
And you can aggregate aggregates.
Yeah, you can actually for example recalculate states of aggregate functions and other stuff. So you have such abilities. Okay, and there is a field, and field, it's like maybe like datum. in Postgres. So it's basically some I don't know how to say union or variant or something like this. So basically, its ability to work with individual values, not with columns, but extract individual value from column. This stuff is mostly not needed because you will work with most of the time with columns, because columns actually provide batch methods. So for example, if you want to sort column, for example, you can just apply get permutation, clone column, and then apply permutation to this column. And it will work much faster because of specializations and other stuff. So you almost never need to work with single values because it will work extremely slow. Okay, there is a bit of introduction about leaky abstractions. So basically, in all interfaces, like I will show you a function interface. One sec, a little bit. And in a function interface, so it's there is method like execute impl, and execute impl, it takes arguments, it takes result type, and it should return column with this result type. And you have a lot of functions. So basically, almost in ClickHouse, we actually create functions and do not care about amount of existing functions. You can see that there are like a lot of functions, and in execute impl method, you actually get array of columns. And here you have not only column, but most of the time you have some triple. So it's a column, physical representation of a data type. You have a data type to understand which data type you're working on, and you have a name of a column. It's most of the time it's not necessary. It's can be helpful for some debug.
In Postgres we call it relation description.
And function take array of columns. For example, function plus will take 2 columns. So in this array we will have 2 columns, and take some result type. And inside this execute impl method, you can do whatever you want. So you can just write a lot of specializations with heavy templates and other stuff, and just return a single column. So this abstraction is I don't know how to say, it's very convenient because you can have clean interfaces, but inside these interfaces you can implement really complex algorithms, complex function logic, write a lot of specializations. For example, I will show you function plus. So in function plus, it takes 2 integers, and one sec, function binary arithmetic. So it's not only function plus. And you can see that there are a lot of ton of switches, ton of other stuff, a lot of templates. For example, if left argument...
How many lines is there?
Oh, it's
300 lines of code to add few integers.
It's 2000 lines of code, but it's like for all binary functions. And for plus, you also use some C++ template tricks. So you register this function plus, you use binary arithmetic overload resolver, and you pass plus impl. So it's a lot of technical details, but what I wanted to show.
Can I ask, what if your plus like different arguments, plus 16-bit integer with 32?
Yeah. Actually, we have specializations for everything, and in result of this heavy template stuff, we will get around 400 permutations. So assume that we have 10 you have 8 integer types or something like this. So you have unsigned integers. For example, let's say 2 basic types: 8-bit, 16 bits, 32 bits, and 64 bits. It's for unsigned. Then you have also for signed, and you have float and double. And you have 10 different types. And each of these, so it's a left part, left side. Each of the also left side can be a constant. So it's another 10, because constant can be any of these types. And you have a right type, so it's also 20. So 20 left, 20 right, and you have in result 400 combinations. So it's a lot of.
That's why binary is 1 gigabyte.
That's why, and also that's not all. in ClickHouse, we also have JIT compilation. So, if you have some function like a plus b multiply c, it will be generated, it will be compiled in, a single function. It will be fused like in a single function for better performance. Okay. So for data types, I talked a bit, and block is just a container. I'll show you because we will actually use it for the code. It's just a simple container. Basically, it's just an array of columns and indexing on top of that. So you have an ordered map. So you can easily get column by its name. Mm-hmm. So nothing really complex. There are a lot of other interesting stuff. So, for example, you can take how table implemented, its a storage interface, and other stuff. So we will actually go top to bottom today. So let me check if so we already built our binary, so we can now start ClickHouse. And when you start ClickHouse, it's interesting. It checks where it's running, details about operating systems. We'll write a lot of stuff in logs, and
the colorful log.
Yeah, actually, it's interesting that in ClickHouse, the whole thing is distributed as single binary. So you have a client. This binary can run benchmarks. It's also a server. It's a compressor. It can format something. It can copy data between clusters. It also can work like Zookeeper. So it's like ClickHouse version of Zookeeper, ClickHouse Keeper. It can also do a lot of other stuff.
Like ClickHouse, get me a cup of coffee.
Yeah.
Brew me a cup of coffee.
Yeah, something like this. And actually, when you run, for example, client, you will get in console. So like in most of the systems. Let's first create a table. I will show you a bit. So basically, you create a table. You specify table name, column name, data type. Then you specify another column. And interesting thing is that in ClickHouse, you need to specify engine for this column. So it will be MergeTree. And in MergeTree, the data is sorted by index, by primary key. And here you specify that we want to sort data by ID. Then you can insert data in this table in standard SQL way. And you can then select this data, for example, with asterisk or with just columns. And what we will actually, and ClickHouse, it has a lot of compatibility with other databases. So it added compatibility with Postgres, with MySQL. It has a lot of commands. For example, you can run show tables, you can run stuff like this. Cool. And everything is implemented. And for example, you can see that you can use, for example, system database and show tables. And you can see that there are a lot of system tables. And here we want actually to take a look at system settings table. So, in ClickHouse, like in any other databases, there are a lot of settings. So there are session settings. There are settings that can be configured only on server start. There are settings that can be configured without server reload. There are settings that require server reload, and there are like really a lot of settings. And some of the settings are like very important. For example, there is setting max threads. And this setting is important because it you can actually, when you select something from system settings, you can see that there is a name of setting, value is changed to not, and description. And we can see that the description for the setting is the maximum number of threads to execute the request. And by default, it's determined automatically. And sometimes people specify fixed max threads for some users, for example. And usually when you connect to the server, you check max threads and max memory usage and some other stuff, to understand how system is configured. And for this stuff, in ClickHouse there are no convenient command like show setting. So for example, there is nothing like this. And in Postgres, there is just command show, and you can specify setting name. So as part of this video, we will implement this command. Yeah, let's do it. So let's go from top to bottom. So in ClickHouse, like in most of the other databases, the execution of a query starts with parser. So I will I will talk about execution stages. So first, query is parsed, and then we will have an AST of this query. Let me
abstract syntax tree.
Yeah, we will have abstract syntax tree of this query. After that, query is after that query, ClickHouse tries to interpret query, and for different queries, for some simple queries, it can actually run them pretty without any complex logic. But for most of the queries, you run query analysis. So there is a folder analyzer. It's actually a new part of new architecture, experimental. So I actually implemented most of the analyzer stuff, and there is planner. It's part of new analyzer planner architecture and can be enabled with a low experimental analyzer setting. And this is a new pass. So basically, query is analyzed. So after that you get query tree, and then then planner takes place, and planner produces a query plan. And after that, query plan is optimized, and then you build a physical query plan. In ClickHouse, it's called query pipeline. And after that, you can execute it. So we will, in this video, we will not cover all these places. We will cover mostly top of it, parsers and interpreters. So let's first start with the parser. Let's find let's find, so basically when you want to implement some feature in ClickHouse, you want to find some similar functionalities so you can reuse some code parts. So you want actually to, when you implement some changes, you want them to look the same as other changes. So basically we see that everything is started with st. Let's check what files do we have here. For example, we have show tables, and show setting, it's similar to show tables. Let's see how it can be used. So there is a complex. So it's part of AST, and you can see that it's part of AST query with output. Actually, you can see you can also show AST show indexes query, and it's a bit simpler. Okay, let's start with this. So it's a bit simpler. We can try to reuse it. So we want to AST show setting. AST show setting query. We modify setting. AST show setting query. So we need the setting name. We modified it identifier, so it will be show setting. We also want to create CPV file, and in CPV file we can also do almost the same stuff. So we can just copy stuff that we saw in AST show indexes query and just change necessary parts. So one sec. In the result, we probably want to clone also setting name when we clone query, and show. Here we have simple show setting, and probably we will have. So here we see that after that we disable highlighting. and wrote a name. So for show indexes, there was a name of a table. In our case, let's just wrote setting name here. After that, if you will not like this format, we can change it back. Okay, so one sec, let me, so it's, we do not need any other stuff. So this should do the trick. And after that, let's...
One moment. Do you call automatic formatting of the code?
Actually, in ClickHouse, we do not rely a lot on automatic formatting. So we have on CI there is style check. You can format your code just with format selection like this. And yeah, yeah, most of the developers use just format selection, but in some cases, for example, for lambdas and other stuff, this formatting does not look good. So so developer manually changed it, and the only requirement is that style check on CI pass. Okay, let me show. So we saw that we implemented this class.
So automatic formatting is a bit stricter than the requirements of CI.
Yeah, it's a bit stricter. Yeah. So let's see how this query is implemented, and so we can see what we need to implement. We see that there is an interpreter, and as I already saw, interpreter interprets query. So that's cool. It's a factory of interpreters, and there is also what we need to do now. We need to parse the query. So let's write our own parser. So we will also use this stuff as our basic functionality. So show parser, show setting query. We implemented show setting name. We modify every other part. Setting query. Okay, and we see that here we parsed a lot of stuff. So here, so here we, this is our interface. We need to implement parse simple method. So this method actually, it has the following signature: the position of token, the node, the result node, and expected. So expected is used for how parser could process further. So it's for the errors during the parsing. For example, you expected something, you added to expected, and return false from parse. So if parse is so if parser was able to parse a query from specified position, it will return true. Okay, let us start here. So we see that there is so let's first so first we try to parse keyword show setting. After that, we actually tries to after that we want to parse some like identifier, so it will be like the setting name, but we also can parser. There is parser string literal, so it seems like
it must be quoted.
Yeah, so we need just parse identifier. Let's try to modify it a bit. So basically, first we try to parse show setting, then we try to parse setting name, and if everything goes good, we have ist show setting query, and for ist show setting query, one sec, we do not have this in our includes. Let's add it. We have a setting name. We can, just create constructor. So this field will not be public. And after we created it, it will be impossible to, modify the setting. So okay, so
yeah, that object-oriented programming, I miss it in C.
yeah, okay, and after that, you actually can try get identifier name. One sec, I will check what this stuff does. So I suspect it does thing that we need. But probably we know that this is identifier, so we'll just use get identifier and setting name. Let's rename this thing as identifier. Okay, well, let's see. Here it expects that we will use it actually expects us that we will just specify it like this. So let's do it. And actually can do something like this. Okay, so first we try to parse show settings. Then we couldn't parse it. Then we try to parse setting name identifier. If we couldn't, parser fails. After that, we try. After that, we get setting name from identifier. We can also just inline it for simplicity. So after that, we have this node, and this parser, as you can see, we just created it, but we did not, edit it anywhere. So probably we need to add it to some factory. Let's see how it's done. So we'll have parser show setting. Parser show setting query. And let's see how this show index is used. So you see that there is a big switch, and we can just use our new parser into this big switch. So there are a lot of parsers. You try to apply these parsers, and if you parsed, that's cool. Okay, now after we have a parser, we need to interpreter to write interpreter. So in our case, you have parser show indexes query. Let's see how it's implemented. No, not parser. 1 second. You have a query, so we return the query, and we need to find interpreter for this query. And you see that there is some type switch, and if this if you will have show setting query, or setting query h. After we have this query, we need to write special interpreter, show setting query. And let's write it the same way as we wrote show indexes query. Setting value for specified setting name and show setting query. Okay, we have a query, so we will not change this stuff. And we need to implement method execute. For simple interpreters, we just need to return block IO, and this block IO, it actually it just return pipeline that you will use, and pipeline will return blocks. So okay, let's
going through all the layers
of abstractions.
Yeah.
Okay, we now need to change here, and here we have a rewritten query.
That was huge.
Yeah, this was actually huge. So one sec. Let's. In our case, I suspect that the query will be show setting query. We have so rewritten query should be something like this. So we select from system settings where name, and here we should have substitution.
Doesn't this constitute vulnerability? Like the user might put some variable that will be executed under their own security context.
It seems that if so basically these queries, when you just substitute some strings, so basically there is additional layers of validation of the queries, and when you just execute a query,
so it's just the same as if you execute this from yourself.
Yeah, just almost the same.
So it must be safe.
Yeah. So we have this rewritten query, and now
it looks much better now.
Yeah, that's it. And now let's implement, and let's put this interpreter into the right place. I actually think that we already put it into the right place. Let's try to build ClickHouse.
I will be much surprised if it compiles.
I'm not sure, compilation from first time, it's almost impossible.
A bunch of code. I was surprised if you didn't mistype something somewhere.
Yeah, we have to take for a while. Let's wait.
So compilation finished.
Yeah, the compilation is finished, and now we can try to check if it will work. So
amazing. No bugs at least no typos from first time.
Yeah. Missing columns, max threads. When name, so we need to add, make it a string. Okay, let's do it. So everything is cool. Just backload.
I think you are selecting star.
Yeah, it's yeah, we just need to backload this stuff. Let's
compile it again.
Yeah, it will work. So let's compile it again. Let's just check that it will not go. While it compiles, let's go through the changes. So basically, one more time, because it seems like we get everything. So everything starts with parser. So we have a parser. We implemented a parser. So here we actually can, clear a lot of unnecessary includes, but it's so basically, if you did not do some, cleanup on code review, guys from core team will point you to that, so you will be able to obviously do this. You have we use this parser here in this big switch. So so we parsed our actual query, and now we need to interpret query. So there is a query.
Let's see if it compiled already.
Yeah, it's
still linking. Yes.
Yeah, it's still linking. So here we have a show setting query, and you can, and after that we need to implement an interpreter. We do this by analogy. So like we already take some piece of code that is similar to ours and modifies. And this strategy, it's a good way to start because there is a lot of interfaces and other stuff, and you can, for example, check which interface implement some already existing code, do almost the same, because a lot of stuff is just like boilerplate. Here we have a written query. We take our query and get setting name. So it worked. And then we added our interpreter to a factory. So we added here include for show setting. Here we added include for show setting query for interpreter, and just cast query to this show setting query and interpret. Let's see if we finished with the linker.
It's linking something else.
Yeah.
ClickHouse.
Yeah. It will take a bit of time. So maybe while it's doing it, we can
format a commit.
Yeah, we can try to prepare commit. So basically, most of the time, what do you need to do before a commit? So utils, check style. So I actually most of the time I run this with sudo because it tests a lot of directories, and sometimes it writes that it doesn't have permission. So to check code style. So it seems like we are good.
Like a serious Linder needs to be a super user.
Yeah. So here while it's doing it, let's open ClickHouse. For some
it's the old version, it's not quoted.
Yeah, for some reason it's not quoted. One sec.
Did you save?
Yeah, I suspect I save it. Maybe let's quote it manually. And after that, let's try to rebuild the. Let's actually maybe just build only ClickHouse target, so it will be a bit faster because it will not link other stuff, so we can get it a bit faster. It's actually interesting why it did not work. Maybe for some reason the code does not work. Let's see. Okay.
Well, can you please get back there? It is looking for a column which is called max threads.
Yeah, because here we want to max threads, and here it's for some reason it's not quoted. So I'm not sure. Let's.
It's not taking a string literal.
Yeah, we just need to to write it as a string literal, and here. So basically we run check style, everything is fine. So after that we can add our changes to the stash. Let's see. Let's wait for a bit. Let's also, while we are waiting, let's check interpreter show indexes query and how actually quoting goes here. I suspect that the same as so here it's implemented manually. Maybe there is something wrong with this function. We can check this later. Okay, let's.
It's not quoted again.
Okay, so
what was the problem?
Yeah, actually, the problem was very simple. When we rebuilt ClickHouse, we only restarted a client, but the actual job of interpreter is implemented on server side. So basically, we run the server, then we run the client and show settings.
It works.
Yeah, it's
committed.
Yeah, we actually did not add any additional changes. So basically, we make a backticks manually. So yeah,
let's leave it as is.
Yeah, let's leave it as is because it's
for video. I think it's
okay. So now let's make a commit. So I have a branch. It's a master branch. Obviously, let's create another branch where at show setting query. at show setting query. Let's commit our changes. Now we committed them. There is an outer. There is commit message. Now we need to add remote ClickHouse fork. I actually, one sec. I will use my fork. So push I need SSH. Let's now one sec. It seems like we already configured everything that we need to push here. So we restarted in this window with necessary SSH agent, so we can, just use it for a push. One sec, I just, for some reason, I did, so here I did not use my git remote rename. Let's just remove. Let's just add. It seems that for some reason I did not add.
You copied git string from.
Yeah, I need this one.
Mm-hmm.
So like this. And this should work.
Yeah.
Yeah, cool. Now we implemented the pull request with our main changes. Let's refresh our branch. We have changes here, and it's obviously a cool new feature. Okay, now when we edit it, I can.
Amazing. This is kind of success.
Yeah, I can add can be tested label here, and we can actually add one test. For this, we have a couple of minutes, so I will show you how it's done. So basically, we will add a stateless test. So we have a page where you can check how testing works in ClickHouse. So for our case, it's enough to write just a functional test. Let's write it. So they are named in increasing order. So let's rename show setting query, right? Let's open it. Set max threads. Let's change to 1. Show setting max threads. So we can add additional tests, but for now, this should be okay. To generate, so basically, stateless tests run this following scheme. You have a query, and you have a reference result. So, for example, what you expect. So you need to generate this reference result manually. So to generate it, you just, use.
We have much similar regression tests in Postgres.
Yeah, so you see one thread, max threads. Now let's commit it.
Cool.
Yeah, let's just push from another window where we already configured.
Great.
So
that was an amazing journey from sources to feature.
Yeah. File to add the host. Yeah, so it pushed everything, and now we can see that here we have 2 commits, and our job here is done. So
Great, thank you, Maxim, for this introduction. I hope you liked it, and now you know how to hack ClickHouse. Looking forward to your new pull requests and maybe some commits, maybe some questions.
Yeah, I actually looking forward to new contributions, so you know how to find the task, and you can do some tasks.
Good luck with coding.
Good luck. Bye.